Afternoon, everyone. I'm just going to give it a few more moments, just let anyone else join, and we'll start in about a minute or so. Okay, good afternoon, everyone, and welcome to number 4 of our Wind Turbines Blade Week sessions, are looking at circularity, and we would say we're going to look at how we look at making wind turbine blades more sustainable. So I'm joined today by my colleague Lorna Bennet, and we've got Simon Pansart from RWE and Gustav Frid from Vattenfall. And yeah, we're going to really delve into some of the topics around sustainability and circular economy and the impacts on wind turbine blades. Should add, if you have any questions, then please feel free to use the Q&A box. There's going to be a question session later on today. We're quite keen to hear your thoughts and as they hopefully put some challenging questions to the panelists here. So Lorna, I guess the first thing we should probably look at is what we mean by circularity, particularly in the context of sustainability.
Yeah, absolutely. And it's a really hot topic at the moment as well. It's even been mentioned by government and media and things as well. So the idea of moving to a circular economy from our linear economy, where we extract materials from the earth, manufacture things, use them, and then dispose of them at the end of their life. So the circular economy looks at how we can reuse and recycle those parts back into the supply chain to make new products and extend the lifetime of the materials we're extracting. So it goes across the board from reducing waste right from the start, with an aim of reducing the amount of material we need to extract from the earth, but then also how do we reduce waste during the manufacturing process? How do we either extend the life of the turbines in this case during their operational lifetime? How can we extend that to get the longest, most practical use out of those materials? At the end of that first operational life, can they be reused, refurbished, remanufactured, or remanufactured into new products, or do they have no use as they are physically, like the blades? Do they need to be cut down into new products or fully recycled back into the initial materials and then remanufactured into new products, recycled into new products? So we're kind of touching bases on all of these things today. So hopefully it'll be a really interesting discussion.
Yeah, definitely. And you touched on some of the challenges there. And I don't want to steal the thunder from Simon and Gustav, but when we talk about the decommissioning and end of life of blades, what's the current issues that we're facing in the offshore wind industry, and how's that sort of driving some of the innovation and development at the moment?
Yes, so there are huge numbers of projects going on in research in this area. We obviously have a few ourselves with our blade recycling report we did last year under the Energy Transition Alliance. We're partnered with the SUSWIN programme and our sister Catapult at the NCC, National Composite Centre. We've got projects looking at the early phases, the waste reduction, and then the future recyclability of new products with Joule and Carbo for Power. All I think have been discussed in other sessions earlier in the week, so I'll not go into too much detail on those, but from our research we did last year, there's no large-scale material separation processes that currently exist to deal with the volume of blades that will be coming off wind farms when they're decommissioned. So if we look at some of the large offshore wind farms, we've got upward of 150 turbines. So you're talking about 450 blades of up to 80 meters in length. And it's the challenges around the logistics of the transportation of those, the downsizing to go through processing, and then the actual separation of, can we extract the fibers and the resins and the adhesives and the polymers into new reusable formats, and then what could they be reused for? So there's a lot of research going into those areas. And then we've had some other really exciting projects that we've seen come up, things like Rewind, where they're looking at how can they reuse whole sections of blades without having to go through that process of actually separating the materials out. You've already got a solid waterproof, strong structure. How could that be used for things like garden sheds or bike shelters or even play parks, as we've seen in the Borders last year? So many different things, everything's still on the table for discussion, and we're hoping to get some ideas from our guests today as well.
Brilliant. I think that's a good segue into introducing Gustav from Vattenfall. Gustav, I don't know if you can join us. Be quite interested to hear the Vattenfall approach to the challenge of sustainability with your current wind farms and the work you're doing at the moment.
Yes, so I'll share my screen here. Let's start with that slide. Okay, cool. Hi, everyone. My name is Gustav Frid, and I'm working as an environment and sustainability specialist within our business area Wind within the Vattenfall group. I'm located in Stockholm and yeah, been at Vattenfall since I graduated a couple of years back. So what will I present for you today? We will talk a little bit on our, first I can say I will not talk that much about Vattenfall as a company or a wind company as such, but I will focus on a recycling pilot that we're doing at the moment. So let's get into that. So Erinforing is a Dutch wind farm. It's located near shore, as you can see here on the picture. It is very shallow waters, and it's next to a highway in quite central in the Netherlands. This is not the ocean you see here. This is a lake, and the site was commissioned 1997 and is now decommissioned. So if you go there today, you will see no turbines anymore. There was 28 of them, and with blades 3-bladed with a weight of 1960 kilos per blade, and the blade length, as you see, 90.1 meter. So this was decommissioned this year, and for that we have decided on a specific treatment of our blades. And maybe you all saw that last fall we announced a ban on landfilling wind turbine blades, and that was not because that was a common practice for us, but rather a conventional way on how to deal with this type of material in the society. But we wanted to enforce that and also push towards circularity and recycling of these materials. However, in this project, we wanted to go one step in advance. So we're actually aiming on recycling all of the materials, as I will speak of later as well. But the blades were decommissioned by a Dutch contractor named FNB. They were collected and transported to their waste yard in the city of Kampen in the Netherlands. And after that, the blades were divided into 3 different streams, you could say. So in this project, we're using repurposing of the blades, meaning that we keep them in the full length. And the second thing we're doing is mechanochemical recycling, and then we're also using pyrolysis recycling. The decision on using these 3 alternative treatments were based on availability. As you all know, this is not an industrialized market, so we needed to see which actors could join us in this pilot trial. but also we wanted to try more than one option. So that's why there are 3 alternatives here. And we also considered like the sustainability potential of these different treatments. As you can see, there is no cement co-processing here, which is a common practice as well. But we wanted to try a concrete recycling treatment instead of a co-processing. So, and in order to enforce this even further, we had ownership transfer agreement signed with all the parties, and that was an sort of insurance, like an insurance for us as a company to know that these actors taking over the ownership of the material actually complies to also our strategic target on recycling and so on. Yes. So this is how it looked like. You saw here, this is the blade coming down from the turbine. And then we had the treatment at the waste yard where the blades were cut. You can see here it's mainly glass fiber, reinforced plastic, and they are using a massive scissor. And it looks big, but consider also now this is a very small blade compared to what Lorna also mentioned in the beginning. So these are 19 meters in total. Yeah, and after this, the blades were loaded on containers and are currently being transported to the different recyclers. So the first one I will touch a little bit on is this mechanochemical treatment process that we're using. So the setup is that this is a life-funded project consortium called Carbon Green, and it consists of several partners that have different inputs and outputs from this project. So it's built around a recycling technology or treatment technology of material, and this technology can treat several different types of waste streams, whichever one is composite material from wind turbine blades. And in this process, the blades are being cut at a company. It doesn't matter like to what extent they are cut, because they are sent to Denmark for pre-treatment for further downsizing to less than 10 millimeter size before they are put in the treatment, recycling treatment in the final step, which is then the mechanical treatment. And there it is further processed into powders, which can then be used in different types of construction materials, as activated carbon if there is a carbon fiber in the input material, and different types of plasterboards and epoxy glue and so on. So there are several products that can come out of this treatment. Looking at the second partner we have is Genkraft, which is a Norwegian company. They are using pyrolysis as the technology, and as you see here, they received a little bit more material, and their process is based on pyrolysis. So what we essentially try to do here in a different way compared to the mechanochemical treatment is that we want to keep the blades cut in larger pieces so that they can maintain a longer fiber size in their coming out of their pyrolysis treatment. And from this, they can make different types of sports equipment, mannequin dolls, but also synthetic oils and gas coming out of the pyrolysis treatment. The third option we had was a college in the Netherlands educating wind technicians. and they wanted 2 blades to use in their education. So one of the blades will be used as a blade to try out different types of repair and inspection operations, and the second one will be used to inspect or to train how to inspect with a drone. So to fly around it and so on, to learn how to do that in a good way. And these blades are kept then in the Netherlands, close by the wind site. So over a little bit to the planning process of this. Now you saw that the 3 different treatment alternatives that we are using for the blades coming from the wind farm that we decommissioned. But I mean, it's not just that easy to go out and find these actors. This is not like recycling of composite material is not an industrialized business, and there is it is a challenge to find good actors that have the potential to treat even now fairly small amounts of material in relation to what's coming. But it's also hard to approach it in the conventional way, stating that we use a contractor that take care of all the material, and then they have their setup with the waste treatment and so on. But here we wanted to ensure that the material was actually recycled. So we took out that part of the tender and stated that we had the mandate to choose a third party for a treatment of the blade material. And that we needed to do to ensure ourselves that we actually ended up in a situation where we knew that the material could be recycled. Because as you all know, in the tender process, you have a few actors answering on your tender, and then you select one of them based on certain requirements and so on. And in case this company that was decided on didn't have a recycling option included in their tender, that would for us then be an issue. Neither would we be allowed to use any of the other proposed recyclers in the other tenders, because that would be considered unethical. So that is kind of a challenge for sure, acting on a market where there are not a lot of alternatives present. So that meant that a preferred alternative recycling technology could be missed out on. So that's why we needed to put it outside the contract. There are also challenges, having all details early on in the project decided on, since this is essentially startups working, not having their full value chain all set, not having all technology up and running at the moment. There are uncertainties in where material will be processed and to what speed and so on, and when they can receive material and so on. So a very flexible approach was required in the planning process. Okay, we can move on to the next one, which is a little bit about the recycling process as such. And just some lessons learned from that was that a plan B is always required. We had that also in the contract, that the decommissioning contractor could bring forward a solution for us to treat the material, which was not landfill. So in this case, the option of cement co-processing was also available in case nothing would work out. But also looking at the pre-treatment in the mechanochemical treatment process, there was a subcontractor that we're pre-treating material, and including more actors, it also comes with an uncertainty, of course. And looking at the material as such, it's not a hazardous waste. Still, there are a lot of challenges crossing borders with it, especially bringing it outside of the European Union. Last, there is still an uncertainty when it comes to market pull for these recycled products. So that is something that needs to be further enhanced by us as a business, trying to find ways on how to use it again in other wind components, but also for the circular economy to further push for actually using these in new products that are of interest for the public, to buy, or private business to buy. Some main learnings. There are bottlenecks in the value chain, and collaboration is the key to solve these ones. Flexible approach. There is not one single solution today that is better than all the rest. We need to find a flexible approach, trying to find different recyclers for material depending on where the wind farm is located, depending on the time frame, and so on. Engage in pilots and R&D in order to start small. I mean, it's better to start and try out than just sit and wait for the perfect answer, and align with the right stakeholders and understand the needs, their needs and expectations. And that's very much present and part of this pilot that we are currently running. So that was all. I'm not sure if we take questions and answers at the moment, or do you prefer taking them in the end?
I think we'll take the questions at the end, Gustav. That was a fantastic presentation. Really insightful few projects there. So if there's any questions for Gustav, then please do pop them in the Q&A box.
Yeah. Okay, thanks.
I'll stop
sharing then.
Brilliant. So that was a really good insight into how Vattenfall in particular are addressing the challenges of now with current wind farms and the decommissioning elements. I'd like to invite Simon from RWE to join me and discuss a little about how RWE are looking towards the future and the future deployment of wind turbines, and how we can look at increasing the circularity and sustainability there. So Simon, welcome.
Yeah, hello, good afternoon. Thanks, Tom. I hope you can hear me all right. I'll share my screen in a minute. So my name's Simon. I am a part of the engineering organization in RWE, have been dealing with rotor blades for many years now, and the last 5 years within this company. And well, I'll pick up where Gustav has ended. So Gustav has explained how Vattenfall deals with the assets that are currently in operation, and so I'll give you an outlook into what's coming next, because we've been involved, or we've been offered by the turbine suppliers on various occasions now, and more new type of blades and blades materials that will make the blades more recyclable. And I'll give you an insight into how we have been doing this last year in one of our wind farms that we're currently constructing. Just a very brief introduction to RWE. Just a minute or so. RWE is an old classical carbon and lignite and nuclear company from based in Germany, and this is still our sort of our root or our basis. But we're with 11,000 employees, but we're moving very fast into the renewable energy business with several thousand employees now. We've been growing very fast over the last years, and we have very ambitious growth plans, both in wind energy and in solar as well. Just to give you an idea of what we currently have, our portfolio is currently around 10 gigawatts of installed capacity, offshore and onshore mainly in wind, but we have very significant growth plans. So we're going to build in the next years many new gigawatts of installed capacity, and many of those offshore. And in one of our projects that we're currently constructing, the wind turbine supplier, in this case SGRE, have offered us for the first time what they consider a fully recyclable blade. And I want to sort of showcase to you how we have picked this up and made this possible to get this installed in our wind farm, and why we have done that, and what our engineering considerations behind that, how they worked. I'll show you a few very simple schematics. So this is the starting point, right? This relates more or less exactly to what Gustav has shown in his presentation. So this is how it would be done today, right? If we have assets in operation today, old assets that need to be dismantled, you take down the blades, you cut them up in pieces, and then you treat them in one way or the other. Often it involves some kind of burning or pyrolysis. I guess the most established way is to use the material, the blade pieces in a cement kiln, so co-processing. Gustav said. So this is what can be done today, and it will over the next years have to ramp up, obviously, because we have all those assets that need to be dismantled. Now, what's new? So what has been proposed to us? That happened last year, and for this specific wind farm in Kaskasi. We'll get there in a minute. So SGRE has offered to us what they call a recyclable epoxy or a recyclable blade. So the process would be something like that. You still take down the blade after the end of the operational life. You cut it up in pieces, but then instead of burning the material off, what they're proposing is dissolving or decomposing the epoxy material in a mild acetic acid, to recover the monomers of the plastic, basically, or of the epoxy, and the glass fibers. And if everything works out like they intend to, it will make those materials available for new products, for new composite products. And so that would be a real recycling process. So we have been offered those blades, and in order to be able to use them and install them on the wind farm, we spent some time and money and made the effort to understand the risks associated with such an approach. Because if we're going to buy those blades and install them on a wind farm, we want to make sure that they will work properly. So one obvious question, or one obvious technical risk with this approach is, if you design a material that can be dissolved or decomposed at the end of its life, so in 30 years time, by applying some elevated temperature and a mild acid, would that be a substance that is sufficiently stable in an environment such as an offshore wind farm, where you might have some mildly acidic conditions, but you also have heat, you have radiation, and you have the time period that this has to last. So so we, together with SGRE, we had to look into how durable such a product is. So the initial tests seem to indicate that that this should work. The same goes for the structural properties. So if you design such an epoxy resin, can it will it have the same strength properties as the classical products, the classical epoxy resins? So so there were tests, mechanical tests, and other engineering validation analysis to show that such recyclable epoxy resins will result in blades with the same structural properties as classical blades. There's also the risk that such materials will not work the same way as classical ones in a mass production environment, right? So what we don't want is that you have a nice and fancy recyclable resin, but it will not work with your traditional infusion processes. So that was one requirement, that that you could basically take the new resin and pass it through the same manufacturing processes as a classical resin. And from everything that we can see today is that seems to be the case. So manufacturing processes are fairly similar to a traditional infusion process, or almost identical. From an operations point of view, so from our point of view, the owners and operators, what we need to know is that if you have such resins, they need to be also compatible with everything we do during the operational life of the asset, right? So repair is probably the most important aspect here. If you have, like the classical blade damages during your operational life, like after 10 or 15 years, you need to repair cracks or erosion or surface damages. Can we do that on such a new resin? Will the new resin, as a recyclable resin, be compatible with repair methods that we used to work with? So this is also one aspect we looked into, and we looked into is such a recyclable blade covered by an existing certification, or do you have to sort of amend existing certifications and spend time and money there to get a certificate updated? So we for this first pilot case, we covered or we made an assessment of all those technical risks, and we came to the conclusion together with SGRE, yes, this is something that can be installed. So we moved on and had a technology pilot installed. So what you see here is a press release that we have issued last year in September, and it says that RWE together with SGRE is installing or will install in our Kaskasi wind farm several sets of those recyclable blades. And this wind farm is currently under construction, and those blades are virtually right now being installed in that wind farm. So we will see whether we will write about our risk assessment, and over the next few years we'll see how well such a blade works in its operational environment. And then the idea is, of course, then 25 or 30 or 35 years from now, when we will decommission those blades, we can do what the plan is: take those blades down, put them into the acid, heat them slightly up, I think it's 60 or 70 degrees, and reclaim the monomers and the glass fibers to make new composites out of it. Any type of product, really. So that's the idea, and we were the first to announce that, which was quite something for our company. Which takes me to the last slide. What's the potential business value? Why would we be doing that? What's our interest in having recyclable blades? And I wanted to make it very concrete here. So these are the two aspects, right? The first one is, of course, it gives us some positive public relations, right? So it makes a nice press release, and it gives a good image. It attracts investment, and I would say it enhances the overall image that wind energy has in the public. So that in itself is already worth worth something. Positive PR is always good, and it attracts investors. The other thing is that we see this more and more now when we move into auctions. When we have to do our tenders for new to be able to build new wind farm projects, it's often an advantage to be able to show that we are installing recyclable blades. It's sometimes even a rather strict requirement already. We see that coming up, that the national authorities require us to make a plan for recycling blades. So this also means a real financial value for us if we can get those blades. And that takes me to the outlook. So this sort of creates a market pull, I would say, and we expect to see more and more of those solutions. And we know that the other large OEMs are working on that. They're proposing this already. Either similar solutions like SGRE by offering recoverable epoxy resins, so similar to what I've just explained, or other even more innovative approaches. So GE/LM, they're looking into blades that are based on thermoplastic matrices, whereas Vestas is also offering recoverable epoxy resins and so on and so forth. So we're expecting that we will see this fairly soon as a standard option on the market. Yeah. So Tom, that was my 10 minutes. End of my presentation. If you're interested, just ask some questions maybe. I don't know if that's the time.
No,
now.
that's good. That's fantastic, Simon. So thanks very much for that. It was great to see the approach RWE are taking with Siemens, and I'm also quite excited to see what will come from the other OEMs, as you alluded to there, and we're aware of some of the projects. So it'd be good to see how that develops. I don't know if Gustav could also join us back on the screen, and we'll hopefully enter into a bit of a Q&A. We've had a few questions come in over the last few minutes. I think the one that jumped out to me, which I think I'm going to start with Gustav, but it'd be good to get your views on this one as well, Lorna. The size of blades and the logistics around moving them, do we see that driving a lot of smaller recycling centers, processing centers, rather than having large centralized plants?
Yeah, shall I start answering that one?
Please.
I mean, what we can see, there's a lot of plans out there, and but there's not a lot of like concrete actual solutions in place at the moment. But a lot of the recycling actors are looking into different harbor setups because offshore wind will be a big thing. The blades will be massive and are in a lot of cases also bigger than onshore, and will be even bigger than onshore eventually. So that's a good location for a recycling actor. Then I think when looking on onshore, it's a little bit different, because there we normally have smaller sizes of blades, and we also have less turbines in comparison. So I would think we need a mixture of different setups here, and depending on the recycler available and where they are located, it also might come with different pre-treatment actions taken already place on the site. Imagine you need to transport something from the north of Sweden, it's a lot of costs taking big parts on trucks. So downsizing earlier on. might be an option there, but that might also limit the recycling options in the next step. So you need to find a match there.
Lorna, do you have anything to add on that topic?
Yeah, I think Gustav's covered that quite well. Obviously, the world's largest blades we had in test in our Blythe facilities last year was 107 meters long. So that's going to be the next generation of wind turbines, and longer potentially, from other companies' discussions and things. So the easiest way to transport those is by boat. So harbours and ports are going to be a major part of infrastructure for offshore wind. And I totally forgot what point I was going to make there, so we should move on, and I'll come back to it if I remember.
No, I think in a similar vein, Simon, the recycling process you're discussing earlier, is this scalable? Do we see an industrialization process around recycling these, using this acid process?
Well, so to be honest, we don't know yet because it has not been done. But I've discussed this question on recent occasions during conferences and so on, with people who are very much involved in the chemists from the large OEMs, and it seems that it's a rather simple process. So the acid involved is acetic acid. So this is a substance that industry is very used to, to work with in large processes. It's a very apparently a rather uncritical substance in large processes. So I think the general expectation is that this could be rather easily scalable. There's a question in the chat that asks also about the disposal of the acid afterwards. So if I understand everything correctly, you can reuse the acid many cycles, and even if you have to dispose it afterwards, it's very easily disposed of. So you can simply neutralize it, and then it's totally uncritical. So from everything I understand from this process, it's something that people think it can be upscaled, but the truth is it hasn't been done yet because there's no need to, right? If it's something that will happen in the future.
Yeah. And sort of on that topic of scale up and cost, there was a question to you, Simon, on the recyclable resins and whether they're going to have a higher cost base than the conventional systems. Is that something you can comment on today?
Yeah, well, I can't really comment on the exact costs in the Kaskasi project. What I can give is probably a general answer that today, quite naturally, those resins come at a higher cost than the standard resins. That's because they're a specific development, and they change a bit the way the blades are made. But it's certainly our expectation that those costs quickly decrease and sort of reach a level that is pretty much comparable to classical epoxy resins, or you would even get to a situation where eventually those recyclable resins become the industry standard and replace the non-recyclable one over the I don't know which period of time, but I think this is clearly the sort of the idea that we have in mind. But today we're not there yet. So if you need to buy recyclable blades, you should expect that this comes at an extra cost.
That's fantastic.
Yeah, can I also comment on that one? I mean, at the moment, the demand for the blades are bigger than the production volumes. We're also using recyclable blades from Siemens Gamesa in offshore projects, but then to a lower volume because of production limitations. But according to Siemens Gamesa, this will be the new blade sets eventually. So it's just a matter of time until this is a standard product in the turbines.
Yeah, and so sticking quickly with the cost basis, Gustav, and the recycling processes you discussed earlier, there's a general conception perception at the moment that recycling is more expensive than necessary disposal. And I wondered if you could be able to add any comment to that.
Yeah, if you only look on the financial side of sustainability, yeah, environment is also a value, and society is also a value, but very hard to put a cost on. So I mean, looking at just the amount of euros that we need to pay, yes, for sure, it's much more expensive, but not that much more, because landfilling is also not for free, and transporting the material there is not for free. So the gate fees for introducing the material either to a recycling treatment route or to a landfilling treatment route is yeah, there is still a difference, of course, but it doesn't have to be that much more. And also now, when we have less ton of material to treat compared to what's coming, I mean, it's essential to take that cost now when we have less amounts rather than when we have huge amounts. So it's so important that some actors start, using these recycling technologies in order for them to scale up and try out and develop and so on. So at least that's how we see it. And we've also worked with developing these cost estimates in our decommissioning budgets and so on. Because when the wind farms were constructed, landfilling was the conventional option. Of course, that was what was calculated on. Yeah.
I think as Gustav says there, it's exactly, it's economies of scale, isn't it? And it comes back to the point I forgot to make in the first question, was around these, whether it'll be a small facilities cropping up in areas or a large one. One of the issues we discussed in the Energy Transition Alliance blade recycling report last year was that there's this uncertainty of supply of this waste material, because obviously recycling facilities and manufacturing facilities needed a reliable input to their processes. And we talk about blade waste being a massive problem for the wind industry, because it is, but in the terms of global composite waste, the Wind Europe report that came out last year says it's only 10% of the total global composite waste. So we are one tiny part of this massive problem. So there's a huge opportunity for this cross-sector collaboration to ensure that these new recycling processes have a steady stream of inputs to their processing, not just from the wind industry, which, as we've said, if you've got life extension, then you've maybe got a slightly uncertain time frame for when these wind turbine blades will be decommissioned. But you've got things coming from the sports sector or the marine industry, where you've got boats that are made out of glass fibre. You've got all these other areas which could also feed into these processes, and it's going to be that kind of cross-sectoral collaboration is going to be key to meet that economy of scale, to bring down those costs. Because as part of our wider circular economy for the wind sector project that we're working on, we're looking at the whole wind turbine, and the cost reduction you get from using recycled steel and other materials over virgin materials that have had to be mined and then processed and then manufactured, that cost has significantly reduced. But it's because we've been doing it for decades, and we will eventually reach that point with composites as well, especially with these new resins coming through, which make it much easier to separate these materials and recycle them.
Brilliant. You mentioned a couple of things I'd like to revisit if we have a chance. Simon, there's hopefully a nice short answer for you. One of the questions that have come in, which is that around the size of the blades and the rated capacity of the turbines that you're going to install.
Yeah. It's I think the ones in Kaskasi, they're 81 meter blades for a rated power of 9 megawatts. This is already, I would say, considered as a smaller turbine when compared to the new projects we are planning. So now we're moving quickly towards 15 megawatts, 20 megawatts, and blades that are significantly longer than 100 meters. So there's a very clear tendency. I mean, everybody knows that here. It's growing fast.
Yeah, I think your point on the growth in the market in terms of turbine size probably leads nicely into the question in the Q&A box about whether we should be looking more at inspection, repair, and sort of relifing after that 20 and 30 year lifetime. But I'd be very good to hear the panelists' thoughts. We'll start with you, Simon.
Yeah, that's a clear tendency also in the industry that I mean, the classical lifetime was 20 years, 25 years, 30 years, but now we're moving into even longer assumed lifetimes, and that's also for a reason. We know today that turbines can operate longer than they were designed for if you maintain them properly, and if you inspect them properly. Or oftentimes you can do that, especially blades. There's sometimes we do that. We take down blades, we refurbish them, like what Michael calls it, like a deep repair. But I would say in most cases that's not even necessary. So today in our assets that reach the end of life, like 20 or 25 years, what we can say is that the blades are still good to go without even a deep refurbishment. So you might want to inspect a bit more often than you used to, but you can still continue operating them. And that's of course also a good option that reduces waste if you want to. So the decision of taking down a turbine is not necessarily because you reach the end of the structural life. It's often because you want to use the site for larger turbines. So that's the real business case. But if you want to operate turbines for longer, you usually can.
Fantastic. So we're entering into the final few minutes. So I just wanted to sort of gather some final thoughts. I think there's some great conversations here about the technologies. I think what's also come across here is the drivers. So the fact that Vattenfall and RWE are both leading the way and pushing these through on the back of their own company's ambitions is fantastic. Very quickly, do we think that we need more of a policy-driven approach here, or do we think that the market drivers will be sufficient? I think, Gustav, it'd be good to get your thoughts on that one.
Yeah, I mean, the recycling technologies are there. What's needed from a legal side is an easier way on how to actually scale up recycling industry. It is really hard in some countries to do trials. I mean, one of the Life Carbon Green project had to move to the Netherlands because of permitting processes that would last for several years in Germany before they could even try out their technology there in large scale. So it is, and that's without having any income, you know. It's only cost for a long time, and for an R&D like a small scale enterprise that's just not possible. So that is one thing. We need to make it easier to recycle. The second thing is that we should find ways on how to enforce circular economy in the society. Like, we can recycle, but we also need to find a proper aftermarket and a pull for these recycled materials in the next step. And that's I mean, it's a massive opportunity for the recyclers that can bring forward an efficient and sustainable technology, because essentially the material is limitless. There will just be coming back these epoxy reinforced plastics over and over again. So there is a need for recycling even in the future. No matter whether we have a recyclable blade or an old school blade, the material will still need to be used in a new product that needs to be bought also on the market. So yeah.
Fantastic. And Simon, I know there's been some announcements this week on some big ambitions for offshore wind deployment in Northern Europe, alongside the announcements by the UK. We touched on it briefly, but how are we going to balance the need for driving sustainability in terms of the materials used against the need for secure energy supply and low carbon energy supply?
Well, I think right now the priority is really on installing as much capacity as possible. So I mean, that's probably the concern that many people have when they look at recycling or recyclability. It's probably a bit lower on the priority list as compared to getting capacity installed, but you know, eventually we will have to get there. I don't know, I don't really know how to balance that, but I feel that you know, for the capacity that we're installing right now, I have the feeling that we will be able to, you know, find proper solutions when the time has come to dismantle those assets again. So it's you know, my personal impression would be, let's install as many turbines as possible right now, and you know, be optimistic about the recyclability 30 years from now.
Yeah, put it in the business case
yeah.
when installing.
I think it highlights why there's the need for both approaches that we've discussed today. So the looking at how we can sort of embed that circularity at the point of design and manufacture, but also looking at how we manage and decommission existing stock and moving it forward. So I've really enjoyed the discussion today. I hope you have, and I hope that those attending have. A quick reminder, this will be available on YouTube. So, you know, if you want to watch back again, then please do. I hope you've enjoyed the session, and our final webinar is tomorrow, and we'll be looking at the manufacturing and the supply chain. So I hope some of you will be able to join us again for that. So yeah, very, very quickly, thank you, Gustav and Simon, for taking your time out to join us. Lorna, always a pleasure to join you on these events. And thanks everyone for joining.
Thanks everyone.
Thank you.